Hi, Phil here again. I'm going to talk to you today about developing assessment tasks for the Senior Maths B course. First of all, you want to think about what's the purpose of the assessment item. Are we doing it just for feedback purposes? If so, which is quite fine, what are we trying to achieve by doing that? Are we just necessarily looking at content, or are we looking at how students are achieving against the standards and the general objectives? The other thing we want to think about too is the balance. I want to think about over the 2-year course, we want to balance out complexities, we want to talk about a range of different types of assessment, and we want to make sure that the students are given ample opportunity, not just over one term where we have equal amounts of content, but think about it over the 2-year period. When we're assessing students, what's really the important stuff? What do we say has to? What's mandatory in our assessment? The two things that the syllabus says that are mandatory are those general objectives, your knowledge and procedures, modelling and problem solving and communication, but also the content. Both of those are mandatory. The other thing I want to think about too is how many times do you want to assess the same, say, general objective? For example, if you want to investigate the strengths and limitations of a particular model, do you do it every time you do a piece of assessment, or do you do it once a semester? Is that enough? And you want to think about how many times you would do that then. It's not something you have to do every single time. We just talked before about the balance over the course of the study. You don't just do it once and say, tick, the students have done that one. You want to give them opportunity over a range of time. The other thing we've got to think about too is that what we'd expect of our students in Year 11, the beginning of Year 11, is very different from what we'd expect them to achieve at the end of Year 12. The course is spiralling just by its pure nature, and so when we're looking at some of the balance that we're looking at in assessing students in Year 11, think about what we're expecting of the students in that year as opposed to Year 12. We'd expect our assessment to be harder in Year 12 because the students have almost finished that 2-year course of study. So when you're planning out your assessment instrument, what should you be looking at? And I've got just some little bullet points there for you to think about. First of all, I just want to touch on the standards. If we're going to measure the students against the standards at the end of Year 12, and I'm talking here about the summative assessment, have we given the students ample opportunity to fully meet the standards according to what the syllabus says? So think about that sort of thing when we're looking at we're doing our assessment. How can we assess? And the syllabus gives us three different examples of how we might do that. The two that are most common would be extended problem solving and just through supervised exams. But the other thing we might want to think about too is writing scientific or mathematical reports. When we think about extended problem solving, the one thing that I really want to encourage you to think about is that just because it's extended problem solving doesn't mean to say that we've got closed problems. In other words, if we're going to ask the students to fulfill a particular task, how can we ask this so that we give the students to extend their knowledge and go beyond the scope of what we normally would? Many assessment items I see in terms of extended problem solving is that they're closed problems, and the issue that I have with that, the only one, is that generally what happens if we have closed problems, that one student's able to solve the problem, and through one mean or another, suddenly all of our cohorts got the answer to that same problem. And we'll think about how can we, other than getting the students to sign a document to say this is my own work, think about how you might get students to authenticate that this work is their own. Maybe there might be times during the working time at home, they have to show you their working as you go, and you might be able to complete a tick sheet to say, this work is, I've seen all of their working behind the scenes, I've seen them working on these problems, and so I can authenticate the fact that this is the student's work. What about a scientific or mathematical report? We thought about taking your students on an excursion and writing a report on that, based on that excursion. We don't have to solve problems like we would do in extended problem solving, but how can we do a feasibility study on whether this is the most optimal means of doing a particular task? And the last one, which we stress most about, is examinations. And we need to make sure that we give students the opportunity to experience a full range of problems. When we talk about a full range, I'll get onto that. We talk about having not only just the standards, but also we want full range of access to technology. We want a full range of content, etc., etc. Formula sheets, a bit of a bone of contention. Your school will have a policy probably on formula sheets, but just think about, if you do have a formula sheet, does everyone get access to that same one? And you might want to think about these things before your exam. Closed and open tasks. For example, if I just wanted my kiddies to draw a function and its inverse, I might have a closed task that says, draw this log function, this exponential function, and make a comment about the graph. I could maybe turn that into an open-ended question by asking them to investigate the graphs of functions and their inverse functions. So then you can ask the student, or the students then can develop their own functions, find out what the inverse function is for themselves, and then construct that knowledge for themselves. The other thing that I see is happening more and more now is labelling anything in assessment items according to what their standard is. There's no syllabus document that says that you must do that, but it is quite common. And there's advantages and disadvantages. One of the advantages for this is the students, when during assessment time, have got some clear directions about what they want to achieve as their outcome. If there's a student who's what we would say like a typical C student, how much time would they allocate to solving standard B and standard A problems versus doing these standard C questions and really nailing those standard C questions anyway. In the past, I have seen some schools that have done a really good job at labelling labelling each of the problems and really giving their students a really, really good opportunity to achieve what they really want to achieve. If we look at the standards in the syllabus, you'll see some documentation that looks a bit like this, and we can have a look at, for example, for a standard C, one of the things in our knowledge and procedures there, we talk about simple life-related problems, as opposed to an A, routine, complex, etc. And how do we handle that, and what do they look like? What makes a problem complex? We know that we can just ask some really hard questions, but complexity also could mean a relatively simple problem from the mathematics side of it, but because it's got so many steps that are involved in it that have to be done in order, it really makes that problem complex. I've got an example there up on the screen. Seven concepts are needed to solve that problem. It makes that problem more complex. All it is about volume and surface area of a cube. However, because of the complexities made higher, because everything has to be done in the right order in order to solve it. What do we mean by routine and non-routine? Well, just quite simple. Routine, we say, is well rehearsed, and non-routine requires some sort of creativity. So well rehearsed, what does that mean? That means that we can practice those sorts of questions prior to the exam. That's what makes them less complex, because they're routine, they're well rehearsed ones. There's nothing nasty or sinister by practicing those things. So non-routine, just make sure that when we say that this one is, we're giving the opportunities for students to do this, that we haven't set them up, and panel people would see pretty simply whether that's been done properly or not. Just a little tip maybe, what you might want to do is have a little tick sheet when you're planning your assessment, and just tick off these things as we go through. In the past I've done this, and you might have some say 4 questions that are routine simple, but only 2 that are non-routine simple, etc. And so it gives you a bit of an idea of what the balance of that of the assessment piece. The last thing I want to talk about is when do you set your assessment? Is it possible for you to set your assessment in the first week of term, knowing that you're going to be sitting an exam in week 9 or week 10? What's the benefits for front ending? It's not about teaching the test, but it's making sure that when you get to week 8, week 9, week 10, that the students are adequately prepared, content-wise, general objectives-wise, in being able to fulfil whatever they need to do in that assessment. So plan early, it's a good thing. And again, it's something you might want to think about in your school. Thanks for watching.